Am I audible?
Yes, ma'am.
Hello. आपको स्क्रीन दिख रहा है?
Yes,
Yes.
ma'am.
Yes.
Start with combustion. Guys, within 5 minutes, what we and then we continue with the controls. Yesterday we started combustion
कितना
boiler.
पार्टी कर सारे एग्जाम चल रहे हैं उसमें लिए
Hello. Please mute yourself. Combustion, the boiler. So combustion control. Before combustion control, you should know what are the objective of combustion control, what are the factors which are affecting combustion control or combustion efficiency, we can say. So first, combustion. Combustion kya hai? It is a very simple process, that is combination of oxygen with the fuel molecule, and in doing so the heat is produced. We require three basic elements for the combustion, that is sufficient amount of oxygen, fuel and kindling or ignition temperature. We are going to relate combustion with the boiler efficiency because combustion, if you consider, fuel and air is required and heat is produced. If you talk about the combustion efficiency is nothing but the boiler efficiency. Why? Because utilities are air and fuel. So how much utilities are required to produce the amount of heat will decide the efficiency. Output by input, that we are going to consider. So output is heat exposed in the steam and the input is heat provided by the fuel. So boiler efficiency is nothing but combustion efficiency, and that is why we are going to increase the boiler efficiency by controlling the combustion. So combustion efficiency is high when there is a perfect combustion. What do you mean by perfect combustion? Each molecule of fuel is mixed with each molecule of air present in the combustion chamber, and it is fully utilized in the combustion process. Then it is called as complete combustion. There should not be any remains after the combustion. Okay. So we are trying to maintain high efficiency, but there are some factors which are affecting the combustion efficiency. So what are those factors? Those are adequate mix, geometry of combustion chamber, dilution and production of water. Adequate mix में हमने study किया. The major factor in the combustion efficiency is adequate mix. Each molecule of fuel is mixed with exact number of molecule of oxygen. So there should be a proper mixing of air and fuel. Second, geometry of combustion chamber. It is also related with the first factor. Geometry of combustion chamber, shape of the combustion chamber should be such that it helps in mixing as well as providing enough space for the mixing of the air and fuel molecule and help in the combustion process. It should be sufficient so that it will not affect the efficiency. Dilution. As we know, air is a mixture of 21% oxygen and 79% other gases. In that also 78% nitrogen. So presence of nitrogen am I audible?
Yes, ma'am.
Yes, ma'am.
Hello, just reply. Am I audible?
Yes, ma'am.
स्क्रीन भी दिख रहा है ना अभी? Screen PPT visible?
Yes, ma'am.
Yes, ma'am.
So we are studying factors which are affecting combustion efficiency. उसमें हमने पहले स्टडी किया adequate mixture, then geometry of combustion chamber. Third is dilution. Dilution में हमने स्टडी किया unnecessarily nitrogen excess air contain oxygen and nitrogen. Nitrogen does not take part in the reaction, but the presence of nitrogen reduces the heat produced in the reaction. So we are going to avoid the excess air in the combustion chamber, otherwise it will affect the combustion efficiency. And the next factor is production of water. The production of water is, it results from the reaction of the hydrogen and oxygen. Gases are present in the air, so hydrogen and oxygen mix with each other and some moisture is produced. Okay, so that is also affecting the combustion efficiency. So we are going to take care of this four factor to increase the efficiency. Adequate mix and geometry are fixed once the boiler unit is manufactured. Okay, the shape and space is fixed. But for adequate mixing, we can use the draft fan so that it can divert the air on the fuel, as well as we can control the excess amount of air by using the control scheme. We will see how. Then objective of combustion control. Objective of combustion control में हमने study किया control of rate of firing, that is air and fuel flow rate must be controlled to control the combustion. Second objective is combustion efficiency control. Just now we saw about the combustion efficiency. It is nothing but complete combustion. Okay, so we are going to design the control scheme which tend or which are towards the complete combustion. Complete combustion इसका मतलब क्या है? Utilization of the fuel and air, complete utilization of fuel and air. So we are going to do it by using some control scheme. Then the third objective is safety control. In doing control of rate of firing and combustion efficiency control, we are going to think about the safety first. So the above two conditions are maintained by using safe interlocks. That is called as safety controls. Combustion control scheme, there are four schemes, that is type 1, type 2, type 3 and type 4. Type 1 may parallel adjusted positioning with no metering. This control scheme, इसमें parallelly two control valves, that is air control valve and fuel control valve, are adjusted, they are positioned parallelly विदाउट मीटरिंग. मीटरिंग का मतलब क्या है? मेजरमेंट. यहाँ पे एयर फ्लो या फ्यूल फ्लो मेजर कर नहीं हो रहा है. दैट इज वाई without measuring we are just adjusting the air flow control valve and fuel flow control valve. The signal for the actuation of these two valves is generated by using the steam pressure steam line. So steam flow is measured by using the pressure parameter. This pressure transmitter will generate the signal and controller will act on that signal. It will generate the actuating signal for these two control valves. Right? So according to the demand, steam demand, steam pressure varies. According to the steam pressure, controller output varies, and according to this boiler controller or pressure controller output, the positioning of the two valves decide the perfect air to fuel ratio which should enter in the combustion chamber. So this is parallel adjusted positioning with no metering. We will study parallel adjusted positioning with full metering. This is type 2. Just look at the diagram. Try to read what is given as the abbreviation. Hope it is visible.
No, ma'am, it's not visible.
Just zoom it on your screen because
Ma'am, your screen is not shared as this.
Visible, ma'am. It's visible.
I have
PPT is
shared. Yeah, PPTs are visible. Okay, अगर डायग्राम में ठीक से नहीं दिख रहा है तो थोड़ा जूम करके देखो आपके डिवाइस पे. ठीक है. Okay, can anyone explain what is shown in the diagram? जल्दी. टाइम कम है, थोड़ा पार्ट कवर करना है आज. What you got from this diagram? Just tell me. क्या दिख रहा है डायग्राम में? Yes, please.
हेलो
हाँ बोलो.
मैम, फर्स्ट ऑफ ऑल जो फ्यूल लाइन है, वो
Okay.
फ्यूल लाइन का फ्लो का जो ट्रांसमिटेड सिग्नल है कंट्रोलर को आएगा मैम.
Correct.
और उसके फाइनल कंट्रोल एलिमेंट के थ्रू फ्यूल का फ्लो कंट्रोल होगा. और जो
Correct. Correct.
स्टीम फ्लो का जो ट्रांसमिटेड सिग्नल है वो जाएगा मैम वो. और जो फर्नेस को एयर आ रहा है उसका जो
Okay.
ट्रांसमिटेड दोनों का जो कॉम्बिनेशन और कॉम्बिनेशन बना के एक इक्वेशन के थ्रू मैम एक पर्टिकुलर सेट पॉइंट से मैच करके एयर फ्लो को कंट्रोल किया जाएगा मैम.
Okay. Okay. Basically, थोड़ा करेक्ट है, थोड़ा आई कैन से इट इज नॉट विथ प्रॉपर फ्लो. ओके, यहाँ पे इन दिस डायग्राम यू विल फाइंड फ्यूल लाइन, एयर सप्लाई लाइन एंड स्टीम लाइन. नाउ डोंट गो ऑन द लोकेशन कि तीनों ऊपर क्यों दिखाए हैं. फर्नेस या कंबशन चेम्बर तो नीचे रहता है, स्टीम लाइन तो हम ऊपर दिखाते हैं डायग्राम में. दिस इज अ कंट्रोल स्कीम जस्ट फॉर द purpose of understanding. We have drawn the scheme like this. Otherwise स्केच अगर आप यहाँ पे बॉयलर का बनाते हो और कंट्रोल स्कीम ड्रॉ करते हो तो इट विल बिकम कॉम्प्लिकेटेड. दैट्स व्हाई टू मेक इट सिंपल we have just consider the signal, we have just consider the lines which are used in this control scheme. So यहाँ पे fuel line and air line, these two lines are connected to the combustion chamber. Drum header, that is called as the steam supply line, is shown over here. फ्यूल फ्लो कंट्रोल वॉल, ये जो फ्यूल लाइन है इसमें जो कंट्रोल वॉल है दैट इज शोन ओवर हियर. सिमिलरली air flow control wall is shown over here, and these two lines are connected to the combustion chamber then. Okay, here the name of the type 2 control scheme is parallel adjusted full metering. Basically, parallelly both the lines are adjusted. I am talking about the fuel line and air line. ऑब्जेक्टिव क्या है हमारा? कंबशन कंट्रोल. कंबशन कंट्रोल करने के लिए हमें क्या करना है? फ्यूल एंड एयर सप्लाई का फ्लो कंट्रोल करना है, राइट? एंड दिस फ्लो इज कंट्रोल डिपेंडिंग ऑन द डिमांड ऑफ द स्टीम. That's why we have to consider this steam line also. So air and fuel flow is controlled by using the steam demand. Here the name is parallel adjusted. So both the lines are, or both the flow are adjusted parallelly with the help of this control valve FCV 101 and FCV 2. FCV 101 is controlling fuel flow and FCV 2 is controlling air flow. फुल मीटरिंग का मीनिंग क्या बताया मैंने? मेजरमेंट. ओके, सो यहाँ पे fuel is also measured and the signal is utilized in controlling the fuel flow wall, as well as air flow is measured and the signal is utilized in controlling the air flow supply. So fuel and air, both the lines are metered and the signals are utilized in controlling the position of both the walls. That's why it is called as parallel adjusted full metering. Okay, previous diagram में क्या था? ये air का और इसका fuel का measurement नहीं था. Only this fuel wall, air wall and this steam line is generating the signal adjusting these two walls. That's all. उसमें addition ये आया है कि air and fuel flow is measured with the help of the transmitter. So here we will see the function. This is fuel line. Fuel flow is measured with the help of FT101. That is flow transmitter 101. You will find some particular symbol over here. What is the meaning of that symbol? Yes. Can you see some symbol over here or over here? FT20. हाँ, क्या है? कौन सा symbol है?
Flow transmitter. Flow transmitter.
Again, please. Not clear. Hello. Flow transmitter. Yes, it is a flow transmitter. So FT is written. 101 is the loop number. वो आपको बाद में समझेगा कि ये numbering क्या है. So FT101 is the flow transmitter instrument, but along with that some symbol is given, some notation is given over here. What is the meaning of that?
Square root extractor.
Correct. It is a square root extractor. But here if you find PT के पास ऐसा कुछ नहीं है square root extractor. So what is the use of this square root extractor? Yes. CSC में आपने स्टडी किया है स्क्वायर रूट एक्सट्रैक्टर.
Orifice plate flow transmitter ऐसे.
It is not like that. Here also the same orifice plate you will see. Right? What is the function of square root extractor? Yes. What is the function of square root extractor? Anyone? जळगावकर फैजान.
I mean, give the value in integer forms and do the size.
No. संकेत. कुरसेकर संकेत. कपाल आशीष.
मैम वो डिफरेंशियल फ्लो रेट को डिफरेंशियल प्रेशर को फ्लो रेट में कन्वर्ट करता है मैम.
डिफरेंशियल प्रेशर को फ्लो रेट में. कन्वर्जन करने का काम करता है स्क्वायर रूट एक्सट्रैक्टर. बोलो. ओके. यस, किसी को बोलना है कुछ?
हेलो हेलो.
हाँ बोलो. यस.
मैम फ्लो रेट से डिफरेंशियल प्रेशर मेजर करता है.
Differential pressure measure करता है. So here also in PT, differential pressure is measured and maybe it is transmitted as a pressure signal, right? But here there is no sign of square root extractor. So it is applicable only for FT or it is a mistake over here. क्या लगता है? उसके लिए पहले तो आपको स्क्वायर रूट एक्सट्रैक्टर का फंक्शन पता होना चाहिए. मृणाल.
Yes, ma'am.
Can you add the answer? Okay. Square root extractor is used to linearize the signal. Please remember, make a note in your notebook. Square root extractor is a unit which is used to linearize the signal and it is applicable only in the flow variable, not in the pressure, level, temperature, density, viscosity, nothing. Only for flow measurement you need square root extractor because the relation, if you find, Q is proportional to under root of delta P. If you remember the quantitative flow Q, if you consider delta P, but it is not proportional relation. It is Q proportional to under root of delta P. So वो जो under root है delta P पे, you need to extract that square. Okay, that's why square root extractor is required in the flow variable, in the flow measurement, so that the signal is linearized and that linearized signal is passed to the controller. This is just like your signal conditioning circuit कैसे रहता है, वैसा circuit रहता है square root extractor का, to linearize the measurement. Got it now?
Yes.
ओके, सो प्लीज रिमेंबर दिस, बिकॉज जहाँ जहाँ आप अभी फ्लो ट्रांसमीटर देखोगे, हर बार मैं नहीं बताने वाली हूँ. यू हैव टू अज्यूम इट कि यहाँ पे स्क्वायर रूट एक्सट्रैक्टर है, ये फ्लो लाइन है, फ्लो लाइन में सिग्नल लीनियराइज करना पड़ता है, इसलिए वो आपको ये यूनिट यहाँ पे दिखाना पड़ता है. जैसे प्रेशर में ज़रूरत नहीं है या लेवल और इसमें टेम्परेचर में ज़रूरत नहीं है, ओनली फॉर द फ्लो. ओके. So this is flow transmitter 101. It measures the flow of the fuel line and transmits the signal after linearization. It transmits the signal to FIC 101. That is a flow indicator controller. Actuating signal is generated. Oh, just wait. Here also airflow is measured with FT201 and linearized signal is given to FIC 201. This 101 is the loop number for the fuel flow loop and 201 is the loop number for the air flow loop. Okay, what I am saying, 101 is the loop number for the fuel flow loop and 201 is the loop number for this air flow loop. Here, set point for both the controller is generated by using the steam demand. So steam demand will change the streamline pressure. Streamline pressure will generate the signal and give it to the, streamline pressure is measured with the help of PT101. This PT101 will give the signal to PIC101, and PIC101, after comparing it with the set point, manual set point, it generates the actuating signal which acts as a set point for both the controllers. Here we require fuel and air in particular ratio. अगर fuel flow and air flow in ratio y, for example, suppose for the combustion you require more quantity of air and less quantity of fuel. Okay, so more quantity of fuel, so let us say double quantity of air is required than the fuel. So if you want to take 2:1 ratio, so that calculator, that ratio station, you need to add either here or here. In any one of the line, you need to add the ratio station. So it is shown over here. It is nothing but fuel to air ratio station. So it will maintain the ratio key for the same amount of set point. This valve is open in such a way that air, double quantity of air should be added for this quantity of fuel. Why? Why it is possible? Because of this ratio. आपने यहाँ पे ही कैलकुलेट कर दिया है कि एयर का फ्लो ये सेट पॉइंट के लिए क्या होना चाहिए. ओके, सो दिस रेशियो विल डिसाइड. So steam demand will change the streamline pressure. Streamline pressure will generate this. Streamline pressure signal is used to generate the set point for both the controllers, and accordingly the controller will generate the actuating signal, and the control valve will open or close to vary the supply of fuel and air to the combustion chamber. This control valve is pneumatic control valve with positioner. इसका symbol देखो आप. This is called as pneumatic control valve, and this is the symbol for the positioner. What is the function of positioner? Make it fast. Faizan? Faizan?
Yes, ma'am.
What is the function of positioner? दो फैजान है क्या, और एक खान फैजान है क्लास में, राइट? ओके, ठीक है, बोलो. व्हाट इज द फंक्शन ऑफ पोजिशनर?
मैम एक्चुअली नहीं पता.
नहीं पता. और लवकुश? लवकुश वर्मा? रितेश वर्मा? शुभम? शुभम वैद्य? अरे बोलो जल्दी. यस, नो, एटलीस्ट गिव सम रिप्लाई.
मॅम ते व्हॅल्व पोझिशनचं काहीतरी आहे ना, पोझिशन.
करेक्ट, करेक्ट. पोजिशनर
मैम
इज
वो
यूज्ड.
एयर प्रेशर यूज करके वाल्व पोजीशन चेंज करता है, उसके लिए यूज होता है ना वो.
यस.
हाँ.
सो पोजिशनर
आई
इज
टू पी
यूज्ड.
कन्वर्टर के बाद होता है. प्रेशर, एयर प्रेशर को यूज करके वाल्व का पोजीशन चेंज करता है.
करेक्ट. वॉल का पोजीशन तो विदाउट पोजिशनर भी चेंज हो सकता है. सो व्हाट इज द नीड ऑफ पोजिशनर? It is not a mandatory, right? It is an additional accessory in the control valve. Without positioner also the control valve will work.
स्टेबलाइज करायला.
Correct. So positioner is basically used to accurate the positioning of the stem on the seat. Because of the pneumatic signal is given to the actuator. Actuator will actuate this stem in the control valve, and the stem will take particular position. But this position is not very much accurate. Okay, because of the vibration or because of some other fluctuation, there may be some, we can say, the accuracy is not there. So what we want, the accurate positioning of the stem on the seat for the particular signal. So that signal is taken as a feedback from this positioner. एक्चुएटर को क्या सिग्नल जा रहा है, वो सेम सिग्नल पोजिशनर लेता है, then it will adjust the stem position so that it will be very accurate. Okay, so it stabilizes the position of the stem in the control valve. So this control valve is with positioner. नाउ इट इज कैरिंग द फ्यूल. इतना क्यों जरूरी है इसको एकदम स्टेबलाइज पोजीशन करना, थोड़ा भी लीकेज नहीं होना चाहिए, अदरवाइज वाइब्रेशन की वजह से अगर स्टेम पोजीशन ठीक नहीं है, इट इज नॉट प्रॉपरली ओपन और क्लोज, सो इट मे कॉज लीकेज. बट बॉयलर कंट्रोल्स के लिए ये कंट्रोल वॉल्व यूज किया है, राइट. कंबशन कंट्रोल ऑन दैट टू फ्यूल सप्लाई लाइन में है, तो फ्यूल सप्लाई लाइन इज अ वेरी critical control line, what we are saying. So we need to decide, we need to select the instruments, devices in such a way that it will satisfy the need for that application. So our need is tight shut off should be there, or accurate positioning of the stem should be there. That is why fuel flow valve must be with positioner. Otherwise, in the laboratory or in general application where it is not so much critical, you will see the control valve without positioners also. Okay. Here you will see airflow control valve. Airflow control valve के लिए damper, the valve body is damper. Why? Because large volume of air to be carried. So small opening or closing, instead of that, such type of valve body is preferred. It is also with positioner. Okay? So please remember these things also along with the function of that control loop. Selection, how to select the component, because it depends on the particular application where you are using that component. Okay, any doubt in this? What we studied, type 2 parallel adjusted with full metering. So parallelly both the control valves are adjusted by using the steam pressure line signal, and metering of the fuel and air line is done, and that signal is utilized in adjustment of the control valve. That's why it is called as parallel adjusted full metering. Any doubt in this?
मैम
हाँ बोलो.
मैम वो PIC 101 है ना बीच में एकदम,
हाँ हाँ.
उसके ऊपर वो ब्रेक क्या है लाइन में?
नहीं
Just
वो नहीं नहीं ब्रेक नहीं है, वो प्लेन लाइन ही रहेगा.
ओके
हाँ मतलब वो पता नहीं, अभी मैंने डायग्राम कहाँ से पिक किया है, वहाँ पे वो मिस्टेक है.
यस
ऐसा कुछ नहीं, इट इज इन कंटिन्यूएशन. ओके, दिस PIC over here is called as boiler controller, or it is called as just wait, master controller. This controller is called as master. You will see three controllers over here: FIC 101, PIC 101, FIC 201. But out of this, PIC 101 is called as a master controller because it is generating the set point, and then the set point is utilized by these two controllers to actuate the control valve. That is why this is called boiler controller or master controller. Okay. The next, that is type 3, parallel adjusted full metering and fuel limiting. So parallel adjusted full metering and fuel limiting, just look at the diagram. और क्या समझता है बताओ मुझे. Yes, who will explain? This you have to read the diagram कि diagram में क्या represent किया है. थोड़ा बहुत. I am not asking the control scheme explain करो. Diagram में क्या दिख रहा है? Yes, please. सुमित घर है. Sumit, can you hear me? Shweta Rathod.
Yes, ma'am.
Can you read the diagram? What you understood from this diagram? क्या दिखाया है diagram में? Diagram समझ के लेना बहुत जरूरी है. Otherwise, what I am talking, where is that abbreviation? You will not get. अभी हम online teaching कर रहे हैं, तो I don't know whether you are looking at the screen and how much you are getting or not. That's why I'm asking you what you can observe in the diagram. First, tell me that. Shweta? Hello. Bhakti?
Ma'am, I can't.
Why? Why you can't explain? Can't you read the screen? लिखा हुआ दिख रहा है वहाँ पे श्वेता.
Yes, ma'am.
ओके, क्या लिखा है वो बताओ मुझे सिर्फ.
Combustion control system, parallel adjusted full bearing and fuel limiting.
ओके, ये टाइटल हो गया. अभी डायग्राम में देखो क्या लिखा है. श्वेता ऊपर से स्टार्ट करो. क्या लिखा है ऊपर? 3 लाइन दिख रहे हैं.
Yes, ma'am. Fuel, steam and air.
ओके, व्हाट आर दीज लाइंस? क्या है ये? फ्यूल सप्लाई लाइन है, एयर सप्लाई लाइन है, विच आर कनेक्टेड टू द कंबशन चेम्बर. एंड स्टीम ड्रम हेडर से स्टीम सप्लाई लाइन इज शोन. ओके, नीचे कंट्रोल वॉल दिख रहे हैं, वहां पे क्या लिखा है? यस श्वेता.
FCV.
ओके, व्हाट इज FCV? उसका मीनिंग दिया है, देखो नीचे.
Ma'am, actually it is blur.
फिर भी तुम बोल सकती हो FCV. F is used for
Fuel control valve.
करेक्ट, फ्यूल फ्लो कंट्रोल वॉल. आगे का कंट्रोल वॉल किस लिए है?
To control fuel flow.
आगे का. ओके, फ्यूल फ्लो कंट्रोल वॉल हो गया है. डैम्पर वाला एक वॉल दिख रहा है FCV2. आई एम
Yes,
टॉकिंग
ma'am.
अबाउट. या, व्हाट इज दैट? फॉर व्हाट पर्पज इट इज यूज्ड? लिखा है उसके नीचे.
Air flow control.
करेक्ट, एयर फ्लो कंट्रोल. तो अभी आपको समझ में आया होगा कि फ्यूल लाइन ऊपर दिखाया है, उसी लाइन का कंट्रोल वॉल नीचे दिखाया है. राइट? तो फ्यूल लाइन इज कनेक्टेड टू द कंबशन चेम्बर. सिमिलरली एयर लाइन ऊपर लिखा है, उसका कंट्रोल वॉल नीचे दिखाया है, दैट इज कनेक्टेड टू द कंबशन चेम्बर. ओके, सो एयर एंड फ्यूल सप्लाईज आर into the furnace or into the combustion chamber. Okay, ठीक है. Anyone else? तेजस सुरवे.
यस मैम.
ओके, क्या समझा बेटा ये डायग्राम से?
मैम बेसिकली ये कंबशन कंट्रोल सिस्टम का डायग्राम है.
करेक्ट.
There's three you can say chambers are fuel, steam and air.
Hmm.
and fuel flow valve is connected at the bottom side.
If possible, now you can turn on your video also, so at least I can see your faces.
Actually, my camera is a little bit.
No, not now, but henceforth, if possible, and for those it is possible, please turn on your videos. I
Okay.
want to see your faces also, please.
Okay.
Yeah, yeah. हाँ बोलो बोलो तेजस. Tejas, you can continue.
I'm on the extreme end side of that. There's a airflow control valve, or you can say a chamber. I'm nothing to say more.
Okay, okay. I will explain it now. ओके तो डायग्राम की तरफ सबने अच्छे से 5 मिनट तक देखा है. ओके मुझे पूछा जाएगा एटलीस्ट इस डर से तो देखा है. नाउ आई विल एक्सप्लेन. Here we are going to study type 3 combustion control, and that is parallel adjusted full metering and fuel limiting. एक एक ऐड हो रहा है. देखो टाइप 1 में हमने क्या देखा था? parallel adjusted without metering, only one pressure transmitter is there and 2 control valve. टाइप 2 में हमने क्या देखा? विथ मीटरिंग, इसलिए 3 मीटरिंग हो गया, मतलब 3 मेजरमेंट आ गया एंड 2 कंट्रोल वॉल्स आर देयर. In type 3, here we are going to measure these 3 parameters, control these 2 control wall. Along with that, we are going to add one thing, that fuel limiting purpose. So fuel limiting की क्या ज़रूरत है? Basically, when there is a load change, so depending on that load change, steam demand, that is steam supply, will change. And when there is a steam change in the steam supply, accordingly you need to adjust your fuel and air control valve, right? But in these 2 control valves also, the control action on the fuel valve should precede than the air control valve. If there is a decrease in the demand, decrease in the supply, what you want? You want to close down your fuel and air control valve. उसमें भी fuel control valve ज़्यादा जल्दी एक्शन में आना चाहिए, right? Why? Because we want to limit the fuel. We want to limit the fuel for the efficiency purpose. We want to limit the fuel for the safety purpose. If the demand is less, supply is less, and the pressure inside the boiler drum is very high, and suppose this fuel and air flow still continually given to the combustion chamber, what will happen? Unnecessarily excess amount of fuel and air will cause the excess heat, and already the boiler pressure is more, so it may cause blast. Second thing, if in the boiler drum, in the combustion chamber, flame is not there, if the flame extinguish, what will happen? The explosive mixture of fuel and air present in the combustion chamber, and in that case also it may cause a blast when ignition temperature is maintained. So what we want in any such emergency case, we want our air supply should be more than the fuel supply always, for the safety reason. For more than this means what? For some condition, this air supply valve should precede than the fuel supply valve. समझ में आ रहा है आपको? मतलब फ्यूल हमें लिमिट करना है, और जब सेफ्टी की ज़रूरत आ पड़ती है तब फ्यूल लिमिट करते समय हमें एयर वॉल ज़्यादा ओपन करना है फॉर सेफ्टी रीज़न. एयर ज़्यादा क्वांटिटी में जाएगा तो ऑब्वियसली इट इज़ नॉट गोइंग टू कॉज मच हजार्ड, बट फ्यूल ज़्यादा क्वांटिटी में जाएगा तो इट मे कॉज द हजार्ड in what we can say, when the flame is not there or when the demand is not there. So to avoid that, fuel limiting is preferred. So how it is done? Please listen carefully. नॉर्मल टाइप 2 हमने स्टडी किया, वो हम पहले देखते हैं, और उसमें देन एडिशन क्या किया है। टाइप 2 में हमने क्या स्टडी किया, दिस इज फ्यूल सप्लाई लाइन, दिस इज एयर सप्लाई लाइन, बोथ द lines are measured with the help of flow transmitter. Signal is given to Fi10, taking this process value of fuel and air line. Along with that, steam demand, that is steam pressure, is measured, and the steam pressure controller will generate the signal. This signal will act as a set value for both the controller, and both the controller will generate the actuating signal. This control valve will act accordingly. Here, in addition to that, you will find this रेशियो स्टेशन पहले यहाँ पे लगाया था, वो अभी यहाँ पे दिखाया है FY201. Here you will find cross connection. Air supply line is connected to some FY101A and fuel supply line is connected to FY101B. This FY101A and FY101B act as a limiter. Okay. If you remember LSS and HSS, सुना है LSS and HSS? Please answer.
Yes, ma'am.
No, ma'am.
Okay, LSS क्या है?
Low selecting switch.
Low selector switch, and HSS high selector switch. Okay, so here we are using these switches over here for the limiting function. So FY101A must be low selector switch and FY101B must be high selector switch. Suppose the air supply is less, this flow transmitter will detect the less air supply. So if the air supply line carries the less amount of air, what we want to limit the fuel before the signal reaches and act on this air wall. Simultaneously, we are giving this signal to the low selector switch. So the low selector switch will select the lower signal and it will limit the fuel supply. लो सिलेक्टर स्विच का काम क्या रहता है, उसको जितने इनपुट है उसमें से lowest one is selected and that is being sent to the further process or unit. So यहाँ पे FY101 को two signals are connected. You can see PIC का output and this airline का output. So if the air supply is less, in normal working condition आपका PIC का output is generating the set point for this FIC because this signal is lower and it is carried over to the FIC. It is generating the actuating signal. But in case if the air supply is lower and this signal is lower, out of these two, the lower one is selected and that is being transferred to FIC101 and which will take control of the fuel control valve. अगर air supply कम है, इसका मतलब fuel ज़्यादा देके कुछ फायदा नहीं है, तो पहले fuel limit करो. That's why this low limiter switch is connected over here. Similarly, if the fuel supply is more, what we want, unnecessarily fuel furnace के अंदर पहले जाएगा, तो it may cause hazard, it may create accident. So to avoid that, what we have to do, the chamber must be evacuated with the air first before fuel enters. That's why if the fuel supply is more, that signal is given to the high selector switch. So the out of these two signal for FY101B, higher one is selected and given to FIC201 to take charge of this control valve. Otherwise, in normal working condition, this PIC generates the set point and this set point is given to FIC101 as well as FIC201. This is only in the condition where it may cause the effect on the efficiency, it may cause the problem for safety. So limiter switches are implemented in this control scheme. Understood this?
Ma'am, one
Yes.
second, ma'am. Quick question.
Yeah. Yes.
If fuel is more high from the fuel supply, that time it will high selector switch select fuel
Fuel signal. Correct. Correct.
through FIC.
Through
Okay,
FI. Yes.
it will control the air.
Correct.
So that
What is
time
our purpose? हाँ.
एअर म्हणजे फ्युएलच्या सोबतच एअर असेल ना, म्हणजे ज्यादा फ्युएल गेलं तर ज्यादा एअर इन होईल असं हे आहे का?
हो, ऍक्च्युली प्रिसीड करायला कोणाच्या
हा.
आधी कोण जायला पाहिजे असा पर्पज आहे आपला. ज्यावेळी
ओके.
फ्युएल सप्लाय जास्त आहे त्यावेळी तुमचा फ्युएल फ्लो सप्लाय जास्त एंटर होण्याच्या अगोदर तुम्हाला एअर सप्लाय प्रिसीड झाला पाहिजे. दॅट इज द पर्पज.
ओके 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 हा हा ओके. रेशो मेंटेन होईल मग त्यांनी. हा.
फॉर फॉर सेफ्टी रिझन. जस्ट इमॅजिन फर्नेस किंवा कंबशन चेंबर आहे, त्याच्यामध्ये फ्लेम जनरेट नाही झाली आहे, पण लार्ज अमाऊंट ऑफ फ्युएल अँड एअर इज देअर. सो एक्सप्लोजिव्ह मिक्सचर जितकं जास्त आहे तेवढे ब्लास्टचे चान्सेस जास्त आहे. इग्निशन टेम्परेचर मिळाल्याबरोबर ब्लास्ट होऊ शकतो. सो सेफ्टी मस्ट बी प्रोव्हाइडेड. एअरची क्वांटिटी जास्त असेल तर इफिशियन्सी अफेक्ट होईल, पण ज्यावेळी सेफ्टी येते त्यावेळी सेफ्टी फर्स्ट, देन वी विल टॉक अबाउट द इफिशियन्सी. Got it? And excess air will not cause the hazard, it will reduce the efficiency. Got it?
Yes, yes.
Yes. Anyone? अजून कोणाला काही डाऊट आहे? ओके. Understood topic or it is a bouncer? ऊपर से गया या समझा है? Please give me the feedback.
समझा मैम.
Okay.
मॅम याचा
Hello.
व्हिडिओ नाही आहे का?
मी चेक करते. लिमिटर्स ऍक्च्युली मी लिमिट स्विचेसचे व्हिडिओ दाखवते तुम्हाला, म्हणजे तुम्हाला याचा कंट्रोल स्कीमचा व्हिडिओ कुठेच नाही मिळणार.
ओके मॅम.
ओके चलो. आय विल डाउनलोड द अटेंडन्स. जस्ट वेट. एक्झामला आजच्या दिवसापर्यंतचा सिलेबस कन्सिडर करा. ओके. बॉयलर टॉपिक इज नॉट एट फिनिश. Syllabus is vast. Instead of vast, I am going slow because if I just speed up myself, you will not get anything, and I don't want that. Okay. Last chapter आपण थोडे speed up ने घेऊया, कारण एकदा हे unit operations तुम्हाला सगळ्यांना कळले की there is no problem in understanding the function of the industry. Right? The function and control scheme of this unit operations are very important. That's why I'm going too slow. Don't worry, syllabus cover करना मेरा काम है. I will do that.